Hey guys, the whitest legs in town have a bit of a red tinge to them today. And that's not exactly the sun's fault, but my own. The unbearable heat of the previous weeks may have slowed me down, but it didn't keep me from doing the things I've threatened with in the last update here. This shed was filled to the top with useless garbage and a rich ecosystem of spiders. I've given them plenty of time with open doors to escape safely. No idea where the spiders went, but the junk has kind of found itself new places where it can still be in the way, but much more subtly. That gives me an entire new playground and 30 years worth of half-eaten insects to clean up. Only to move back in with a ton of higher quality junk. This is like the best junk I own at the moment, making my moving methods especially questionable. But I really didn't want to disassemble the perfectly aligned rails again. I'm sure that flimsy handrail would have supported this 200 kilogram team in case of an emergency. Right? But it all went surprisingly fine, and that way I think I've exhausted my good fortune allowance for the next few months. Just look at this beautiful fit. It looks like this location was made for the machine. So I thought I'd make it a bit more permanent and a bit more good by welding the highest load frame parts in place. If you hadn't guessed it already, me wearing shorts while doing this gave me the red legs. I shouldn't be allowed around power tools. This doesn't need to be pretty. Some genuine bird poop stick welding will be plenty good for this. Well, good, because that's the best I could do anyway. Originally, I had prepared this news for myself, to avoid explaining to anybody how I managed to destroy a staircase, a front door and a fancy CNC machine at once. But since everything went smoothly, I can now use it to hang these gantry parts. And to give them a good shaking. Since I'm no longer restricted by any kind of weight limit, I can now do what I already wanted before I got all those steel parts. Polymer concrete ad nauseam. This is a product called Silimix 282. It's a mixture of silica sands whose smaller grain sizes will perfectly fill in the gaps in between larger grains. That way it only takes around 8% epoxy to turn the stuff into a real high-tech conglomerate that's dimensionally stable, vibration cancelling, and very, very heavy. It may look a little dry now, but when that nearly ideal gap-filling property comes into play, it'll be absolutely perfect and any excess epoxy will just be in the way. I don't think these hollow steel beams were particularly prone to bending before, but when filling them with compacted polymer concrete, there is no need for thinking anymore. They'll essentially become stone. Here's the best part. Check this out. Similar techniques are used in large industrial machines as well, but they are going one or multiple steps further with hydraulic compression and stuff. I had a bit of a problem with the machine base wobbling on the uneven enclosure foundation. But polymer concrete was the answer to that as well. I cast another bed surface into the enclosure and let it cure with the machine sitting on top of it. The roof isn't screwed down yet. As you saw, I don't have very good lighting in the CNC shed yet, so why don't we take a look at the fancy spindle stuff before I take that down there. someone on the Discord server, please join if you haven't already, noticed that the water chiller looks very similar to a common Chinese unit. And sure enough, there isn't really anything special about it. It's basically just a radiator. So we've got to be a little careful with too high ambient temperatures, or upgrade to the similarly common Chinese refrigerator unit. I think they may have modified it a little bit though, with a higher quality switching power supply, and a few more trigger conditions for the alarm output, like multiple temperature and a flow rate sensor, power down and maybe reservoir empty. Most of the magic is happening here though. Check out these incredible connectors. The green one is for sensors. I'm not sure if there's an RPM or position sensor, but definitely over temperature and status of the tool clamping mechanism. The orange one is for power and protective earth. And then there are two more push-in connectors for the liquid cooling. The junction box is made in Germany by Rittal. I think I'm going to try and get exactly the same model again for a PC, motion controller and GPIO card, and the servo drives. This one's purely responsible for the spindle. From right to left it has a compressed air input and 3 outputs with their own pressure regulators. 2 outputs are always on simultaneously. Lösedruck will open the clamping mechanism and allow a tool change, while Kegelblasluft will blow out the same to avoid getting any dirt clamped in there. The third output is for sort of a purge system. I haven't found any instructions for that yet, but usually that's opened for a few minutes after a job is finished and the spindle is stalled, to prevent any residual moisture creeping into the internals. The VFD is a nice one, with vector control, USB and EtherCAT. I think it's currently configured to receive an analog control voltage. But I kind of want to try and talk to it digitally. I bet there is a lot of interesting drive parameters one can read from it. This is a big mains filter, a 24-volt power supply, and a safety relay that does things when things are happening, like spindle over temperature or loss of compressed air. I think we're about to reach the first chips milestone next week, and the next public video will hopefully be full of vague hints that we've already progressed that far. But I actually want to make it about lubrication. I know, I was also appalled when one of you suggested that topic to me. Like my first thoughts were of Keith Fenner's goopy old oil tin. But when done correctly, it's actually a much more beautiful topic than that. The Fogbuster minimum quantity lubrication is an old hat on all CNC related YouTube channels. But it's always pretty nevertheless. A real oil-based central lubrication system with hopefully a 3D printed progressive valve has never been shown by anyone. It guarantees to deliver equal amounts of lubricant to every output, all mechanically. And it doesn't care about pressure differences or anything while doing so.